I'm going to show that the Laplace transform of y prime is equals to s multiplied by y of s minus y evaluated at 0. So we want to show that, and I'm going to use the definition of the Laplace transform. If f of t is defined for t greater than or equals to 0, the Laplace transform of f of t, which we denote by f of s, is equals to the integral from 0 to infinity of exponent of minus st times f of t with respect to t. So in this case, we want the Laplace transform of y prime. So wherever we are having f of t here, we replace with y prime. So that we have the Laplace transform of y prime is equals to the integral from 0 to infinity of exponent of minus st times y prime of t with respect to t. This t in parentheses is emphasizing that y is a function of t. But we can rewrite that y prime there, that's the derivative of y. So we write our y prime is equals to the derivative of y with respect to t. So that our expression becomes the integral from 0 to infinity of exponent of minus st multiplied by the derivative of y with respect to t. So that's the expression that we have. But if we are looking at this part here, we see that that's a product of functions of t. So to evaluate integrals where we have a product, we have to use integration by parts. For integration by parts, the integral of u dv is equals to uv minus integral of v du. So in this case, we choose our u to be the exponent of minus st, then differentiate this u with respect to t, then it will give us the u is equals to minus s multiplied by exponent of minus st dt. And then our dv, we choose it to be the derivative of y with respect to t. For us to get a v, we have to integrate, and if you still recall, when we integrate a derivative, we get the function itself. So when we integrate this here, what we get there is our v is equals to the function y. So we then go on and substitute into our formula for integration by parts there, so that our expression will then become exponent of minus st times y, then the limits 0 to infinity, minus the integral from 0 to infinity of y multiplied by minus s multiplied by exponent of minus st with respect to t. But this s here is a constant because we are integrating with respect to t, so we can take it outside. Then we'll have the minus, by the minus it will be a positive, so that our expression becomes exponent of minus st times y, the limits 0 to infinity, then plus s multiplied by the integral from 0 to infinity of exponent of minus st times y with respect to t. So that's the result that we have for now. For the limits on this first part here, as t approaches infinity there, exponent of minus st approaches 0 if s is greater than 0. So for the upper limit, we have 0. Then for the lower limit, when we substitute a 0, it will then be minus. Then minus exponent of 0 here, exponent of 0 gives us a 1. Then we'll be multiplying by the y, but now y evaluated at 0, the lower limit. So it will give us minus exponent of s times 0 multiplied by y evaluated at 0. And then we go on and look at the other part there, this integral here. For us to clearly see this, we have to revisit the definition of the Laplace transform. We said that the integral from 0 to infinity of exponent of minus st times f of t dt is equals to the Laplace transform of f of t. But in this case, we are having a y in the place of f of t. So what you are finding there, that's the Laplace transform of y, which we can write as an uppercase y. We are saying y, which is a function of s, just because a Laplace transform is a function of s. So we write that Laplace transform of y as y of s, an uppercase y. So it will be plus s multiplied by y of s. And then we go on and evaluate this one. Exponent of minus s times 0 gives us a 1. So we remain with minus y evaluated at 0 plus s multiplied by y of s. But we can then just rewrite this expression, put the minus there on the other side there, so that it will give us s multiplied by y of s minus y evaluated at 0. So that's the expression that we have there for the Laplace transform. So what you are saying here is the Laplace transform of y prime is equals to s multiplied by y of s minus y evaluated at 0. But usually when you use this formula here, we do not write this s. We just write it as an uppercase y. Because sometimes if we write it like this, it might confuse some people, and they think that it's a s multiplied by y multiplied by s, then they get s squared, which is not the case. Here it is saying y, a function of s. So we can just rewrite it as the Laplace transform of y prime is equals to s multiplied by y minus y evaluated at 0. It's just an alternative way of writing that formula there.